Okay, think I'm live. Alright, so that is normal latency to the stream, but not too worried about that. So this is going to be a live coding session where I'm attempting to implement the game of chess using Godot. That's pronounced Godot, and I'm using 4.1 version of the engine. So okay, so let me get started. I think this is probably going to be a long session. So let me get started with a new project. Just going to call it chess live. Let's go to oops. I'm just going to select the mobile renderer because this is not a graphics heavy project. It's just going to be a simple game of chess, so we don't need any of the other modes. Let's create the project. Okay, and we have the 2D scene over here, ready to go. Let me just clean up some of these lines by just removing show origin, I guess. Yes, that's much better. So the blue rectangle that's seen here is basically the viewport, and this is basically where the camera is going to be when you press play. So this is going to be the area that's going to be viewed. So before I proceed, let me just make sure that my stream is actually live. Audio is coming in. Not too worried about that. So this is using 4.1 version of the engine. Okay, so I'm able to hear my audio, so I'm assuming I'm live and going ahead. So I'm going to start by rendering a simple chessboard on the screen, and the thing is Godot already has a bunch of different nodes that you can use. And since chess is mainly a grid-based game, a tile map is something that's going to suit well for this purpose. So let me just go ahead and create a tile map. I'm going to call it the board. And to begin with, let's just possibly assign a script to it. Let's just call it board. Let's create script. And you can see that Godot already gives you certain presets. So there is a function called _ready. It's called when the node enters the scene. This is basically like something like a constructor, so you can write code inside this that's going to run when the node first gets initialized, and the process function is going to be called every frame. Now I don't really need this function for now. I'm going to remove it, and let's just maybe print _ready once, just to make sure that everything is set up and working fine. And we'll have to save the scene. I'm just going to save it the same way. It's going to appear here in our resources directory. Let's go ahead and press play. And no main scene has been defined, just select the current one. And you can see we are not rendering anything, but the output log shows the print statement that we had put. So good to go. Let's go ahead and see how we can render certain things on the tile. So first, before I begin to render something, I need something called a tile set, which is there as part of the tile map. But the thing is, it's currently not set to anything. As you can see, it says empty. I need to create a new tile set, and now the tile set doesn't have any sources. So basically, these are the sprites or images that you want to be displayed on the cell. For a chessboard, I just need a square with a color on it, with a solid color. So what I do for this is I basically just go to this website called Piskel. This is a website where you can just quickly paint certain sprites and have them exported. As you can see, I already have a sprite here which contains two different squares, one for the dark square on the chessboard and a light square on the chessboard, and the total resolution is 128 pixels wide and 64 pixels high, which means each of these squares is 64 by 64. So I'm just going to download this, and let's put this under the specific project that I'm working on. So go to projects, live. I'm going to create a new folder called assets, maybe. Let's call these squares. Now if I go to Godot, the assets folder should be present, and you can see that this texture is over here. So let's create something called a new atlas. So you can create multiple atlases as part of a tile set. So I'm going to have a different atlas for the pieces, something different for the squares themselves, and so on. And let's call this squares, and the texture is going to be assigned over here. Let's automatically create tiles. And now if you see, the tiles are not really split properly. This is because Godot doesn't really know what the resolution of our tiles are supposed to be. So let's go ahead and fix that. So if you see under the tile set, the tile size is currently set as 16 to 16. I'm going to make it 64 by 64. And now if you come back here inside the tile set, you also have to set the texture region size over here. It's going to be the same, 64 by 64. And now you see the corresponding squares are getting highlighted properly. So now I have two different textures that I can use in my script as well. And first let's go ahead and try to render just one texture. Now the way a tilemap works is you can give the coordinates as 0, 0, 0, 1 and so on, and you can just set what you need as what texture you want in that specific tile. So for example, let's go ahead and call this function called setCell. Now this function is available to us because our current script extends tilemap. So we are under the scope of tilemap, so all the functions that are under a tilemap are accessible to us. So you can see setCell, and I can actually go to the documentation to understand what this does. And you can see over here that setCell takes in a layer, and this is the layer on the tilemap on which you want to set this specific texture. And the coordinates is it's actually a vector to integer. What this means is your coordinates can be 0, 0, 0, 1 or so on, to specify which cell in the tilemap we are targeting. The source is basically the source which you see over here inside of the tile set, and you can see the source ID in this case is 0, because this is 0 indexed, and this is the first atlas that we have. And then you have something called atlas coordinates, which if you hover over the specific tile over here, you'll be able to see the atlas coordinates. It's 0, 0 for the dark square and 1, 0 for the light square. So what I'm going to do is I'm actually just going to go ahead and first create a layer inside the tile map if it doesn't exist already. So by default there is one layer, so I'm just going to call this squares, and the layer, what we need to put is a layer index over here, and the layers are also in 0 indexed, which means that this is the first layer, so this is index 0. And for coordinates, for now I'm just going to hard code maybe 0, 0, then say inside the source, this source is the source that we just spoke about in the tile set. So you can actually hover over here and you can see the source and the atlas coordinates. Let's look at rendering a dark square. So put 0 over here, and the atlas coordinates is also a vector to I, and it's 0, 0 for the dark square. So let's put this, and we should actually be good to go. So let's see, and you can see that we have rendered one tile successfully. Now let's try to change some things about this. Maybe what if I change the position to 3, 3? You can see that it's now at the since it's 0 index, it's at the 4th row and 4th column. And let us now try to render the other tile, which is actually at 1, 0. So if I just change this to 1, we should be seeing a light square there instead of the dark square. Let's go ahead and run, and yes, now you can see that the light square is rendered. Now I am going to just run a loop and render a grid of sorts. So let's first declare a variable for the grid size, which is going to be an integer, and let's set this to 5 as for testing. And what we're going to do is now we're going to run a loop. So loop through the rows and the columns of the grid, and just set the cell at every position. Let's just set the dark square, and instead of hard coding the position, I'm going to say this is I, j, and that should ideally be it. Let's go ahead and see how this works, and you can see that we are rendering a 5x5 grid, but it's just hard to see. And you know that inside a cell, in an actual chessboard, the squares are going to be of alternate colors. So what we're going to do is, if we're going to see if it is a dark square tile, then we are going to set the coordinates to 0, 0, or if it's a light square, then we're going to set it to 1, 0. So first, using the position, which is I, j, we are going to determine whether it's a dark square or a light square cell. Now I know that when you begin an actual chessboard, you can actually go ahead and check out any chessboard over here. You can see that it starts with a light square, and the bottom left is a dark square. So basically, if the sum of the row and column divided by 2, if the remainder is 0, it's going to be a dark square, is what I believe. So anyway, we can just test that. So what I'm going to do is create a function is dark square, given the row and a column, and it returns a boolean. So let's go ahead and say row plus column modulo 2 plus 0, and let's see. So can just create a square is of I, j, and what we're going to do is also set the atlas coordinates, which is this variable over here, based on if it is a dark square, else it's going to be the light square tile, and just use that to set something is wrong about this function, because this is underscore over here is the same name for the variable, so it got confused. Let's go ahead and run that, and yes, now I can see it's tiling it properly, but I think the colors are shifted. So first let's make this an actual chessboard with 8x8 grid. I'm able to render it, but the bottom left needs to be dark and the top left needs to be light, which means we just flip this, and now you can see we have a proper chessboard that's rendered. Alright, so now it's actually time to render the pieces. what I'm going to do is create another layer on the tile map for the pieces. Let's go ahead and add an element, pieces, and now I also need the texture from which I'm going to sample and display the pieces. So I'm going to create a new atlas. But before that, let's go ahead and find the actual sprites that we're going to use for the pieces. I believe just pieces with transparent background. And this is important because if you are going to change the background and the chess pieces actually have a background along with them, it's not going to match up. So this works out perfectly for us because we have a transparent background and all of the pieces are available in this. And this is something that Godot will actually be able to auto slice, or if you give the actual texture resolution, it's going to be able to split it properly. So let's just go ahead and save this inside our assets. I'm just going to call it pieces. Save, and it should appear in my assets here. I'm going to create a new atlas. Again, let's call it pieces and assign this texture. Yes. And now you see right now the borders around the pieces are not perfect. It's attempting to split it, but it wasn't able to do a really good job. But I think we should be able to figure out the resolution, and you can see that it's 60 by 60 for each piece, and the overall resolution here is 360 by 120, which means that you have 6 pieces on each row. It's 60 pixels wide and 60 pixels high. That is something you can specify here. You can see by default it's at 64. I'm just going to change this to 60, and you can see now it splits across nicely. And it's currently, I think, the same way you need to specify the tile, because the source index now is actually 1. You can see that for squares it's 0 and for pieces it's 1, and the atlas coordinates obviously accordingly will have to be changed. So what I'm going to do is actually first create a map from the pieces to the correct atlas coordinates, so that I don't have to hard code it every time that I render a piece. So let's actually go ahead and create that map. So the map is going to be pieces, or more like piece to atlas cost map, which is a dictionary. And actually I'm just going to create an init function for that as well. Let's call this init. I'm just going to copy this entire thing. Please. Okay, now I'm going to do this initialization maybe even before I render the board. It doesn't really matter. And what this needs to do is map a piece to the specific coordinate on the atlas. And I can kind of see a pattern here. You can see that all the black pieces are on the have the y coordinate as 0, and all the white pieces have the y coordinate as 1, and then it's just a matter of looping over an index. So we just need, and they have the same order, which is nice. So all I need to do is create a string. Let me call it pieces. And what we're going to do is, we are going to go with something called the FEN, which is a way to it's a notation to capture any position that's there on the board. So in a one-line string, but this is still a little ahead. What we're going to do is each piece is going to be denoted by a character, which is like this. So if it's a black piece, it's going to be lowercase. If it's a white piece, it's going to be uppercase. And the names of these are self-explanatory. This is a pawn, this is a knight. The reason it's not k is because that collides with king. you have a bishop, you have a rook, and then you have a queen. So we know the exact order in which the pieces are in this. So we are just going to create a string. Let's see, it starts from the left here over to the right. So it's queen, king, rook, knight, bishop, and pawn. And what I'm going to do is actually run a loop through this. So for index, I think it's length, yes. Let's do the black pieces first. So for black pieces, what you're going to do is the map. You need the piece which is going to be index. Let's just have that in a separate variable. And the atlas coordinate for this is going to be a vector to I. And we know that the black pieces have a y coordinate of 0. So it's going to be something comma 0, and I believe this is just going to be index. So 0, 1, 2, 3, 4, 5. So the atlas coordinates are captured here properly. And for the white pieces, it's going to be similar. Sorry, but the thing is the white pieces are always in uppercase. So I'm just going to convert this to an uppercase. And I think this should be good enough. So this will initialize the map with all the atlas coordinates that I need to render the pieces. Now let's quickly have a function to set piece at position. So piece at position, where you give a piece which is a string, and then a position which is again an integer vector 2. So what this is going to do is actually just this, but now we are going to be setting it on the pieces layer, which is the second layer. So the index here is going to be 1, and the position is just a position that was passed in. And this is going to be the source in the tilemap, which for pieces it's 1, and the atlas coordinates, this is something you're going to look up from our map over here. So let's take it from the map and pass in piece. We should be good. Alright, so let's test out this function. So I'm going to say set piece at position, and let's maybe place the black bishop, which is a lowercase b, and I'm going to give in a random position which is just, I don't know, maybe 4, 5. Hopefully this works. Let's go and see what happens. And you can see that the black bishop is rendered right now 0, 1, 2, 3, 4. So that's the 5th column, and then it's 0, 1, 2, 3, 4, 5 over here. So we know that we are able to render pieces. So let's actually make sure that the map is initialized fine. What I'm going to do is I'm just going to loop through the entire map and set all the pieces to random positions. So for piece in the map, what I'm going to do is this is going to be piece, and the position is going to be, I believe we have functions to create random integers, random integer in a range, I believe. Yes, you give a from, and then 2, 0, 7 are the bounds of the chessboard. So let's say we create a y and an x, and then we pass that as a vector 2. So what it's going to do is iterate over every piece, assign a random vector 2 for the position, and attempt to set that piece at that position. So let's see how this works. Okay, there's something that went wrong. All of the pieces are black for some reason. So maybe this didn't work the way I intended it to. Let's see if we can actually get the map. Since I have declared it at a high level globally, we should be able to view the actual variable should be able to inspect it on the board. Yes, so you have the map. I see what happened. So for the white pieces, I should have set the y coordinate to 1. I've set it to 0, so it's getting set to the black piece texture again. So I'm just gonna fix that quickly, run again, and now I can see it's actually being set at different positions. So although there are only 5 black pieces, and that is possibly because it got overridden by a white piece, 5, or there is again something wrong. So there is a king which apparently did not get set for both. Not really. Yes, so there must have been an overlap. I can just run this again to verify that, and you can see all the pieces are actually getting set properly. And since it's random, there's a possibility that 2 pieces clash and one of them gets overridden, but I can see that the piece placement seems to be fine and they look good. Now we have a function to set a piece at any position on the board, which is good, but what we'd like to do is actually initialize the board with the standard position, and instead of hard coding every position over here, what I'm going to do is here is where we are going to use the notation that I spoke about in order to capture the actual position on the chessboard. So as you can see, the fen describes a chess position. It's a 1-line ASCII string. So what you can do is actually capture the entire current position on any chessboard using this notation, and this is basically the starting position of an actual chessboard. So what we're going to do is let me actually open the Wikipedia for this, and this actually defines the notation and tells how we can actually parse it. So first let's go ahead and create a function to do this. Set board position, I guess, or this just takes in string and it's going to set the board. So I'm going to keep a sample of the standard starting position over here, and now let's quickly go through the logic and see how this can be implemented. So a fen record contains 6 fields, each separated by space, and you can see each of these denotes a different thing. So there is piece placement, there is something about the active color, about castling availability, en passant, half moon clock, and the full moon number. What we are mainly interested in right now is just the piece placement data. So to keep things simple, I'm going to ignore the rest of it. So first I'm going to start with parsing the string for the piece placement and place the pieces accordingly. So each rank is described starting with rank 8, which is the top of the board, and rank 1, which is the bottom of the board. So it goes from top to bottom, which is good for us, and that's a slash in between. So what we basically do is we are going to split this by the slash, and before that, first let's take the piece placement data into a separate variable. So piece placement data is going to be, so let's first split the fen into multiple parts, which is going to just be split by space, and the piece placement data is going to be the first part, so it's just going to be 0 index. And now inside of this we can see that this is going to be the piece placement data. So it's going to be this. What I need to do is split this by the forward slash, and each of this is going to denote a specific rank on the board. So let's call it ranks is going to be piece placement dot split by the slash, and just for debugging I'm just going to print each rank. And right now we don't call this function, so let's just call set board with the standard fin. So set board, pass in the string, so it should ideally print out each of the ranks. Let's go ahead and run that, and you can see we are printing each of the ranks. So each of this denotes one row on the chessboard, and what you can see here is each character represents a piece as usual. The lowercase is for black pieces and the uppercase are for white pieces, and whenever we encounter a number, it basically denotes how many columns or cells we have to skip, so in that particular row. So let's go ahead and implement this and start placing pieces. So instead of iterating by rank, so the thing is the rank is something I need as a number, because when I set the piece at a particular position, I need a vector 2i basically, which is a row and a column. So let me actually call it a row and a column. Rank start, I believe it's size for an array. So for each row, the rank is going to be this, and then we need to basically iterate over each rank and see whether it's a number or a character. So if it's a character, you know that it's a piece, you just place it right there and move on. If it is a number, then you know that you just have to skip that many cells, which means we need to keep a variable to keep track of the current column. I'm just going to call it column, and it starts at 0. And let's go ahead and now iterate for, it's called value in the rank, and now we need to check if the value is a number or if it's a variable. So if the value is a valid integer, which works perfectly for us, then just skip that many. So I'm just going to skip by increment column by that many, and else, now you know it's a piece, place it here. So this is going to be set, and use the utility we created before, and the piece is basically just the value because it's a character, and the position is again going to be vector 2 with integers, and put row and column. Looks fine, not sure about this, but let's give it a go. Okay, getting somewhere, but this is not the way a standard opening position looks like. Oh, I think I'm not incrementing call after setting a piece, and that's why it's taking the last piece. So let's just increment the column by 1. Try now. Okay, very interesting. So we were able to actually somehow parse the fin string properly, but it's just that the row and column is inverted, and this is possibly because of the way Godot does indexing on row and column in the Tilemap. So let me just try flipping the column and row over here, and yes, now we have the proper starting position. All the squares look good, and the pieces are properly arranged. And just to make sure that we have the right parsing logic, what I'm going to do is try this with a couple of different positions and see if it renders the right mode. So this is the standard starting position, so let's just keep this over here. I'm not going to delete it. And for testing, let's go ahead and pull up maybe a couple of other ones. We had the chess programming link over here. Okay, so after a couple of moves, this is going to be the fin denoting this position. I think it's not really clear here. See if I can expand, zoom in on this. Okay, so we need the pawn, white pawn to have moved up, the black pawn to have moved down, and then the knight to have come to f3. Let's see if this is actually captured if I set this as our condition, save and run it, and yes, this means that we are parsing the friend and displaying it properly. Now all we need to do is we need to set up some kind of movement. Right now there's no way to interact with the board itself, so let's start with that. I'm going to set this back to the original starting position, and let's go ahead and start capturing some inputs. So Godot has this function which fires on every input event on the viewport. So what I'm going to do is I'm going to check if the event is a mouse event. So it's input event mouse button. I'm actually just going to print the event because I'm not really sure what properties it contains. Let's go ahead and run that, and if I click somewhere, okay, so it fires 2 events. I believe it's because it also captures mouse up and mouse down as 2 different events, and you can see pressed is true and pressed is false when I release the mouse. I think that's about it. And since this is a mouse event, I think even scrolls count as events, and you can see that the button index is different if I scroll. So button index 1 is for the left click, and pressed is true. I think that should be enough for me to detect if it's a left click. So let's actually go into the documentation to understand a little more. So the button index is a mouse button. If it's a mouse button left, yes, the index is 1. And what we're going to do is add a check for that as well. If it's a mouse event, what I'll do is if dot button index, so there should be a get index is mouse button left, and event dot is pressed, I guess, yes, and then I'm going to print left mouse click. So let's see if this works. Click on this, yes, left mouse click is registered, and you can see it's registered just once. And if I click with my right mouse now, I don't see that coming, scrolls don't come. So we have a way to properly detect left mouse clicks. Now the thing is, we need to detect where the mouse was clicked in order to understand which piece the user is targeting. So let's at this point get the mouse position and translate that to the corresponding position on the tile map. So what we're going to do here is, let's see, so I think since we are extending tile map, there should be a way to get the mouse position. Mouse, I think it's mouse underscore position. Okay, there is a local mouse position which comes as part of a canvas item, and you can see that the tile map actually inherits from canvas item, which means we should have this function as part of this scope. So let's go ahead and say get local mouse position, and yes, it is available. This returns the mouse's position in this canvas using the local coordinate system. And the thing is, now you need to basically translate this to a position on the tile map, because the tile map really doesn't know what this position stands for. This is a different vector, so there is a utility for that, which is local to map, and you can see it, this will return a vector 2i, and I just need to do this, and this is going to give me the position on the tile map. So we are going to just call this maybe click position, and let me go ahead and print that. So let's say I click. So the thing is, right now it also registers clicks outside of the board because we haven't added any kind of validation yet, but Let me start from the top left. So you can see if I click on the black rook, prints 0,0, and the bottom right rook, it's 7,7, and all of the other clicks should also register just fine. So now we have the click position, but how do you know if the player wants to move this? So I'm going to just follow a simple interface for moving pieces. We are not going to implement any drag and drop yet. So it's just going to be if the player clicks on a piece, then you select the piece, and they click on another position to move the piece. So for example, the other thing that needs to be taken care of is to make sure that if a piece is already selected, then you assume that the player wants to move. So let's go ahead and actually create a kind of section here. I believe this is not the best way to do this. You can create a separate script and have events fired from this script and then handle all the movement in a separate script. But right now, again, I'm not looking for optimizing or refactoring the code, which is something I'll take up later. Right now, we just want to get something quickly working. So let's create a selected piece position, which is going to be again to I. And the thing is, I cannot assign this a value of null. So, and also I cannot give it a vector 2.0 because that is a valid position on the board. 0,0 is actually a valid position on the board. So what I'm going to do is I'm just going to by default make this -1, -1, and if this is the vector, then I'll assume that no piece is currently selected. This is the default value of the selected piece position. Now this is what we're going to do. So at this point, you know that something was clicked. Let's see. Okay, if piece is not selected yet, update selected piece position. If piece already is selected, attempt to move the piece. So if the piece is not already selected, then the selected piece position is going to equal -1, -1. What I'm going to do is just update the selected piece position to the click position, and else what we're going to do is then it's basically a we are attempting to move. So since we are not yet implementing the move logic, let me just print move requested from the current piece position to the target position is going to be the new mouse click, which is just the click position. Let's just move these commands inside these statements to make them more contextual. No longer need to click the print the click position. Let's go ahead and I'm going to say selected piece at position. This could also be click position, doesn't matter. I'm just going to test this. Save. So it says selected pieces position 4,6. Just click here, move requested from here to here, and if you see, my subsequent clicks always count as move requests. So what I need to do is once the move request is done, I need to clear the selected piece position and set it back to and clearing the selected piece position in our case is just setting it back to -1, -1. Now let's go ahead and test it. So the first click selects a piece, the second click attempts to move it, and then the next one is also going to select, and you can see alternate clicks are going to be selects and moves. There are going to be cases where we might want to not request a move, we just want to clear the selected piece position, but that's something we need to take care of later. So right now, let's just quickly attempt to implement move. So we know from where to where the player requested a move of the piece. So let's just do the move. In this case, it's a move request. So let's say we have a function which is move piece, which is from position, and then you have a target position, which is, I'm just going to call it 2. So what we are going to do is on the tile map, we need to set the piece which is there in the current position at 2 position, and then clear the tile which is there in the current position. So first we need to get the piece that's there. So let's see how we can do that. Right, so currently we don't have a way to query the tile map to figure out what piece is there, because the tile map at this point is just a renderer. It doesn't keep any data about what kind of piece is there or anything. So what we need is actually an internal representation of a board, which I'm going to sort out now. So I think the traditional way is to create a 2-dimensional array to represent the board, but in this I'm just going to try a different method. I'm going to create a dictionary, and it's a dictionary from a position to a piece. So you can always give a position and look up what piece is present on that board. So let's go ahead and also add an init for this. This is the initialize the board, which is going to just loop over again. Well, technically you don't need grid size, because you always know that the grid size is going to be 8, but I'm just trying to avoid magic numbers around the code. So let's just do this. And board of vector 2i, I comma j is at this point null. So you set it to null to begin with, and when you set the actual board, you'll update the board over here. So set piece at position, do this, and you also say that board, and so let's create a variable for the position. This goes here, and board at position is going to equal value. So now we have a dictionary from a given position to the actual piece that's there. And actually we could just check this. Yes, again, if we go to the board and see what properties we have. Okay, there should have been a board over here. Not sure where it is. Script. Yes, so you see the board is currently a dictionary size 32, which seems to be weird because you should ideally have had 64 entries in the dictionary. Let's see what's going on over here. So what I do is, when I initialize the board, so all of this is null, which makes sense. Oh, it's just because I didn't call in board. So let's go ahead, initialize the board, and play again. And now if you go to the board, you're going to see that it's of size 64. All the cells, all the positions that don't have any pieces on them are just going to have nulls, and the ones that actually have pieces have the actual piece notation over there. So this is good. So what I can do now is I have the capability to give a position and figure out what piece is there at that position. So what I'm going to do here is get the piece which is there on the board's from position. For some reason autocomplete didn't kick in. I believe it's possibly because the game is running. Let's come back here. So you have the piece exact piece that you need to render. So what I can do is set piece at position, the piece at the target position, and then what you actually need is to clear the older position. In fact, if we can just test this to see what happens. So if I do this, I selected the piece here, then I click here. We are not yet calling move piece. My bad again. Move requested from here. So let's go ahead and do move piece. And this is from position to the click position. And you can see right now this breaks for some reason. Right. And I know what is happening. That is because once we made the move, we also did not update the board. That is something we'll have to do. So when you do set piece at position, you not just do this, also update the board, which is position is the piece, and we could also have a helper to clear piece at a certain position. So let's go ahead and create that. Clear piece. So I actually just needed to be clear position. I don't really care what piece was that. Just need to clear it. And the board is going to have null at that place. Now the thing is, if you need to set a blank cell on a tile map, all you need to do is go to the documentation actually, and you will be able to see here, if the source ID is set to -1 and the atlas coordinates to -1, -1, or the alternative tile to -1, the cell will be erased. And this is actually what we want. And if you see, you can see that the default values on the function are already -1, and the class coordinates are also -1, -1, which means if I don't pass in these parameters, it's just going to erase whatever is there at that cell. So let's close the docs for now, go here, and just going to say do this, which means it's just going to clear this position. And let's go ahead and do that when we move our piece. So first we set piece at the target position, and then we clear position at the from. Let's go ahead and run this. Now you can see it actually updates properly, and you should be able to make subsequent moves as well. So the other problem right now you can see is a piece can just move wherever we want, which is obviously not how chess is played. So what we need to do is this, plus I also believe that there are problems if you attempt to move something from outside the tile map. So let's say I click an empty piece and then I attempt to move. Yeah, it's going to crash because we are not checking if there is any piece at the current position. So what we need is basically a validate move. So this is not really move piece. It just reads nicely because it says move piece from position to position, but all right. I'm going to say validate. This is also going to take a from and to, and let's make it return a boolean. It's going to return true if it's a valid move, or false if it's an invalid move. So this is going to be kind of a tricky function to implement. So again, let's take the piece which is there at that position, but then you don't know if from position is even within the bounds of the board. So let's again create a helper for this. So is position within bounds value. And if the position is less than 0 or if it's greater than 7, then you know that it's out of bounds, so just return false. And we'll do the same for the y coordinate. And otherwise return true. So if bounds, so if the from position or the to position, either of them are outside of bounds, then just return false. And for now we'll just the other thing to think is, if the user selected a tile which does not actually have a piece in it, this is going to fail because inside of the board, when you pick this, the piece is going to be null, and then when you attempt to actually move the piece, it's going to again look that up in our atlas map and it's not going to exist. So what we will do again is, if piece is null, again return false, and say return true over here. I think you just have to do a double equal to, you can't do an S. It's not Python. Okay, so this should be good enough, and this is something which I possibly should do inside of move piece, but let me just do it outside. If is valid move, then attempt to move the piece, otherwise don't move it. And either way, whether it's valid or not, we just clear the piece position. Okay, let's try to run this over here. Right now all of these are valid. What if I attempt to click something which is outside? I'm just going to click on one of these blank cells, then attempt to move to another blank cell, and you can see the move was requested, but since it's an invalid move, it just did a kind of no op, it did not select anything. Alright, and the other thing is, this becomes a problem when if I accidentally click on an empty square and then I want to select this pawn, it doesn't, because it counts that as a move request because it assumes that you selected the empty tile. So what we can do is, if it is an empty tile, then don't set the selection. Then basically just clear the selection is what I want, right? Let's see how I can handle this. Should be a simpler way to do it. Just look at piece position, piece is not selected yet. So if this is present on the board, or rather right, you also need to make sure that it is within bounds and it's not null. So alright, we have a function to check if it is within bounds. That is something you need to do anyway, so let's go ahead and set that. Is position within bounds of click position, then you do the selection. And it's also not an empty square, so let's just do position is not null. Okay, so more like quality of life updates. It says selected actually, but this is supposed to be inside of the if. Right, so now I give a move. Now I can click as many times as possible inside or outside. It doesn't affect anything. And if I click outside, it should ideally just clear it. And that's the same check which I'm going to have over here. If the click position is within bounds, then attempt to do this or just clear the selection. Something wrong. Is this because okay, put a colon, should be fine. Let's try to run this, and I can click as many times, it doesn't do anything. If I select something, then I select outside, it clears the selection, I believe. Yes. And as I mentioned, right now you can move from anywhere to anywhere, which is not ideal. So let's go ahead and implement some sort of validation. So is valid move. This currently just checks for being within bounds and you having actually selected some piece. So right now, since we have moved that check over here, you technically don't need it here. You can assume that this will always give a valid from and to position. Let me check if I can remove that. If the click position is within bounds, then here this cannot be null, so you cannot select a piece that is null. Let's try to actually remove this and see what happens. So no surprises so far. I think it actually works fine. Yes, so that is because we have actually moved the validation to the higher layer, so it still works out fine. And now this is checked within bounds, and now we are going to do validations on each of the pieces based on what piece it is. So let's go ahead and implement specific functions to check for those validations. For example, if it's a pawn, it can only move in certain ways, and so on. So let's say let's call it is valid on move, or rather what I'm actually going to do is I'm actually going to generate a list of positions. So it's going to be generate valid positions, which is going to return an array of positions. So the move requested was here. I think you just need a from position to generate this. And what that means is, given a position, I can always look up what piece is present there, and based on that I can run certain validations on the board. So let's actually just start with a pawn, and what I'm going to do is piece is just get the piece at that particular position, and I'm just going to put a simple if. And the pawn here is actually slightly tricky because if it's if it's the player pawn, it can only move upwards, and if it's the opponent pawn, it can move only downwards. And again, the interface could possibly allow the player to flip the board, in which case the directions get flipped around as well. So to keep things simple, I'm just going to assume that white is always at the bottom and black is always at the top. So based on that, I'm going to attempt to set the direction of the pawns. So first let's check if the piece is a black pawn or a white pawn. Then I'm just going to say generate valid pawn positions. Yeah, so generate, I can actually also pass the piece in here so that I can avoid lookup. And this is going to just return valid pawn positions, piece, and the front position. And if it's not, I'm just going to return an empty list. So what we're going to do is, so when we check whether it's a valid move or not, I'm going to first generate valid move positions. Given the front position, and check if the target position which the user has requested for lies within this list. And this is just going to be return to position in valid move positions. And we can remove this. So right now, since we don't have any valid positions, all of these are going to basically return empty lists, and every position is always going to be invalid, and we are not going to move it. So I'm going to put that to the test, and you can see I'm attempting to move pieces by clicking, and none of the pieces are moving, and this is good. So what we need to do is now start adding all the valid positions for a pawn. So let's first start with setting the direction. What that means is, as I mentioned, what I'm going to assume is if it's a white pawn, it's always going to move upwards. I'm not going to support board flipping yet. So the direction in which the pawn can move is going to be up if the piece is white. We actually know that this is a pawn because this is specific to pawns. Else it's going to be black, so it's going to move downwards. And let's generate all the positions. So to begin with, I'm going to keep it simple and say that the pawn can only move one cell upwards or downwards. So with that in mind, let's say create valid positions. I think you just append the current position of the piece, which is the from position plus direction. I could obviously directly set the array at this point, but I'm going to be adding a lot more appends, so I'm just going to leave it like this. Let's check the pawns. I can't move it 2 spaces yet, but okay. So we have a bug. I'm not able to move any pawns. This was stupid because I need to return the valid positions instead of an empty array. Okay, and you can see you can always move one step ahead. Pun unintended, basically, and the black pawn it can't move backwards. The white pawn can't move backwards this way either, or to the side, or anywhere. But we can always move one step ahead, and this works. So let's then go ahead and add the logic that if the pawn is at the base position, it can move 2 steps. So see, base position is, so the base position, if it is black, it's going to be from the top of the board, so the file number would be 1. Again, I'm currently using the, so let's actually just use the same if else here so as to not confuse it, and the base position would be 6 in that case. If it's black, it's going to be 1, and what I'm going to do is if it's currently at the base position, which is denoted by the X, I believe, or the Y, I'm not really sure. Second. So this is where Godot's tilemap can be slightly confusing. The thing is, see this, so you see selected this at position 6 and it moves to 4, 4, which means this is basically rank number or rather the index number 6. That's what I need to check for. So if position.y equals the base position, then you also have a move which is 2 steps, so we're just going to multiply this by 2. And now we should be able to move 2 steps if we start from the base position and from the other end as well, but if you try to move 2 steps from anywhere else, it should just fail, which it does, and you should also be able to move 1 position if you want to. So okay, the base position check is working. Now let's look at what happens when a pawn has to capture. So that's the only time when a pawn can move diagonally. Now this is basically the reason why pawns are possibly the hardest to implement, because all the other chesses, all the other chess pieces, the moves are actually well defined, and you can never move, in a different direction conditionally. The directions are always defined, and it's just about moving. But the thing is, with a pawn, it may or may not move in this particular direction based on the situation. So what we need to now detect is there a piece diagonally 1 step away, which is an opponent piece, in which it's a pawn capture, and we need to allow that. So before I move ahead, what I'm going to actually do is I'm going to add a quick debug helper of sorts, which is incidentally also there in Lichess. And the way it works is when you click on a piece, it shows you all the possible positions in which that piece can move. So this would also be really good for helping us debug, and what I'm going to do is I'm going to actually add that. So first let me go to the tilemap and set up another layer. It's gonna call it highlight maybe, or moves, not sure. Let's call it possible moves. This is the layer in which I'm going to show a particular sprite in which if the piece can move to that position. So what I'm talking about is something like here in Lichess, if you go to Lichess, so when you click on a piece, you can see that it highlights the particular squares to which the piece can move to, right? So this is very handy while playing as well as for debugging. So what I'm going to do is implement something like this, and since the colors that I use are actually the same as the Lichess colors, I'm going to basically just use the same color for this green. Let's see if I can use the color picker to pick this. Okay, I was able to pick it. Now let me just quickly create a sprite for this. So actually I need this to be reset to a smaller sprite. I'm just going to keep it 32 cross 32 and add this color to the palette. Just keep this, I'm going to fill this. It might be a bit too huge actually. We possibly just need a 16 cross 16. And what I'm going to do is, now let's export this image as possibly highlight, I guess. Okay, this is yet another atlas. Let's go to the tile set, add an atlas. I'll call it highlight. Then put this over here, create the tiles. The texture is 16 cross 16. Okay. And now what I need to do is I need to create a highlight cell function, either that or I just use the set cell to do it. But let's actually just go ahead and create the function. Basically create a highlight cell position. What this is going to do is it's just going to call set cell yet again. Should have that usage somewhere. Let's just take this highlight, and here again we are going to put it on a different layer, which is possible moves, which is layer 2 in this case. The index of the layer is 2. The position is what got passed in. The source ID, as you can see over here, is 2, and the atlas coordinates are always going to be 0, 0 over here. You see, not sure why it doesn't show up. Okay, but basically I know that the atlas coordinates are 0, 0. So, which is incidentally I believe 0. Yeah, so vector 2.0 is just 0, 0. This is just a neat way of doing it. This is to highlight a cell, and should possibly also have something to clear highlight. Actually, you would never clear one highlight in particular. You would always clear all the highlights. So let's just call it clear highlights. And what we need here is to figure out all the cells in this particular layer that have been set. And I believe there is a function in the Tilemap to get that. So this should be a get somewhere. Get layer, get cell tile data. Okay, I think this is what we need. So get used cells given a layer. So returns an array with the positions of all cells containing a tile in the given layer. It's considered empty if its source identifier equals -1, -1 is alternative, which works perfectly for us. So I just need to do this. So let's get used cells in layer 2, and is there a way to set something like this? So I'm just going to call it highlight cells, and for cell in cells, or is there a way to just clear? We can kind of disable the layer, but that's not what I'm looking for. let's see. Okay, what if I was to do it in this? For each cell in the layer cell dot, I don't have a position, okay, but we have an x and y. So I'm just going to say at this position, just go ahead and clear. Okay, so we have functions to highlight a cell and clear highlights. I don't know how well they work actually. So let's just go ahead and whenever a piece is selected, at that point we get all the possible moves and highlight it. So generate valid move positions, which thankfully takes in just a from position, I believe. Sorry, yeah, just takes in a from position. So which is the clicked position. Valid move positions is going to be this. Then I'm going to say okay, so basically your highlight cell just takes in one position. So let's actually call this highlight positions. I don't know why I called it highlight. So which is going to take an array, and then I'm going to do the same thing over here for each position. Just set the highlight. Okay, and that means it's just going to be highlight the valid move positions, and just before you clear this point, you clear highlights. Let's go ahead and check how good that works. So if I click on the horse, we haven't added any valid move positions for horses yet, so it's not going to show. But for pawns, it occasionally shows for some reason. It actually does show the possible positions. So let's go ahead and click here. I see what's happening. So if you click on a pawn, and then let's say you decide, no, I want to move the pawn from here. If you click on this, it doesn't reselect this pawn. Instead, it counts as a move request from here to here. So it's kind of an annoyance. So what I'm just going to do is, if there is already a piece selected, and then you click on a tile which has a friendly piece, then I'm just going to select that piece. If the position is within bounds, and here you check if it's a valid move. So instead of that, what I'm going to do is this portion only happens if check if friendly piece is selected. So again, I would need a couple of util functions, I believe. So basically, first I get the piece at the current position, which is I don't want this selected, so already selected piece. It's going to be selected piece position. And if it's present on the board, Alright, so if the target position is not on if of if this is not null, it means it's a piece the target position. Check if friendly. So what you need to basically do is to check if it's friendly, need basically is same color and then two pieces. So piece 1 and piece 2. So how do we detect if they are the same color? Is there a way to detect if it's uppercase? It says 2 upper, so I don't know if it is actually currently uppercase is upper is lower. Okay, so what I'm going to do is I'm just going to do this by figuring out what the color of the piece is. Black pieces are going to be, let's use the same string that we used before. So if both of them are inside of this, then you know that it's the same color. Is that how I want to do the check? If piece 1 belongs to this and piece 2 also belongs to this, then it's the same color, else they are different colors. So the assumption is that you never pass a null inside of this. If and two pieces, either that or both of them are actually white pieces. So actually let's just flip this around and this one are different colors. Actually, I think it can just make sense to have a get color given piece, which returns piece color, which can actually be an enum, can be black or white. So I'm going to say this returns a piece color. Black if piece is else, I'm just gonna call it white. Okay, and then what this basically does is get color of piece 1 is not equal to piece 2. So you could also check for, and the reason I'm doing the check for different colors is because this is also going to help us in figuring out if there is an opponent in our pawn validation. So let's go over here. There's a piece, check if friendly, if not different colors. So of the already selected piece and the new piece that's selected, which is this one. then just update the selected position. Piece, so selected piece position is going to be the click position. If none of these is true, then attempt to move the piece. But I think what happens here is whenever you select a piece, it will clear highlights. This is going to cause a lot of confusion. So let's actually just let's create a signal for this. I think because it's getting slightly complicated. I'm going to say piece selected, or is it just going to be on? Is that how you emit a signal? Let me see what. So this is how it's emitted. So we'll call it piece selected, and then the position. Set this. Right now nothing is listening to the signal. That is something I can solve. I'm going to go to the node. You can see there is a signal. I'm going to connect it to the same node. We have a listener over here. So here what we're going to do is move the highlighting logic over here. So plus the highlights, and over here we say emit piece selected, and then selected piece position is passed as a parameter, which is the same thing I'm going to do over here. So there is a piece at the target position, then it emits the signal, otherwise it does not, and we should be good here. Let's see if something can go wrong. So emit signal happens, it highlights positions, and then it clears highlights over here. See what happens. So the position is within bounds. We already had a piece selected, and then the target position. Maybe I should just return here. Because the input handling basically ends. Let's try this out. So it doesn't clear highlights, which possibly so basically always clear the highlights when you start this. See how this works. And then you return. Okay, we have highlighting, which actually shows which moves can be done. Now this is also good for debugging. Right now it doesn't work for any of the other pieces. And now you can see there was a bug where it actually shows that you can actually move to this position. which is not the case. So what you need to do is, if it is not already occupied, only then you attempt to move there. So is occupied by friendly piece, then it's just blocked. If it's occupied by an opponent, it depends on the piece, because a pawn cannot capture straight up. So let's go ahead and say what we can actually do is just filter out the positions where there are friendly pieces. Let's create a helper which is to check if it's occupied. So what this just does is board of position is not null, which means it's just occupied. Now whether it's occupied by an opponent or friendly is something we'll have to take care of, but for a pawn it doesn't matter. So let's create target position. It's going to be this, and if not position occupied, then you append this position, and that's the same with that's the same with the two steps. I think this entire thing goes over here. Let's go target position is this, and just remove this. Let's try, yeah, and you can see this position does not appear for the pawn because it's occupied and you can't move there, and should be the same case if you had multiple pawns of friendlies as well. Now let's start to code the pawn capture logic and allow that as a valid position. So what I'm going to do is, again, capture positions. So what we need to check is if there are only two diagonals for the pawn. If in any of the two diagonals there is an opponent piece, it's a valid position. So let's go ahead and first calculate the diagonal positions. Going to be front position plus the diagonal is always one step either upwards and then right and left, or downwards and right and left. So what I'm going to do is I'm just going to add so it's not to do, it's the direction of the pawn plus right, and then you have the diagonal on the left. So you have two diagonal positions, and now for each of this we need the position to be occupied, and we also need it to be of opposite colors. So if our different colors of the current piece, which is our pawn which is moving, and the piece at that position, the position they are different colors, then it's a valid position. So just append this. I think this should be good enough. Let's go and try this. So we have this, and now you can see we see the diagonal as a valid move as well. So if I do this, yes, it is a capture. There is one other move though, which is the en passant move for the pawn, which is kind of an edge case. I'll get to that later, but right now I can see that the diagonal capture is also a valid move. I cannot move anywhere else. I can only move to the valid positions. So let's go and capture here as well. And the black pawn can also capture over here. So most of the pawn movement is actually done. I think I would like to be able to move the other pieces now, because right now I cannot move any of the other pieces. So let's quickly go ahead and do this one by one, starting with possibly the rook, I guess. I think I should have a match or a slightly better way of representing these here. Right now I'm just going to write a bunch of if else's. Let's go ahead and copy paste this. I need rook positions here, and we don't have that function yet, so which I'm going to create here. It's also going to return a list of correct positions that can move to. Yeah. So it's going to be similar to the pawn positions. What we're going to do is create a valid positions array and just return that. Let's go ahead and see. Now the rook can move in 4 possible directions. So what I'm going to do is let's look through the 4 different directions. You have up, down, left, and right. So in each direction, I'm going to say the target position starts from 1 step away in that direction, and while the target position, while it's not occupied, then just append it to valid positions. And this is a variable. Okay, I think this should be good enough. But the problem is this doesn't allow for the rook to capture, because it's just going to check if the position is occupied. So while the position is not occupied, keep pending, and then when it exits, let's see. So first you need to check if and then when it exits, it means the position was occupied. Either that or the target or we went out of bounds. So if the target position board, then you have an occupied position. Now just check if it's an opponent. So colors this, So right now selecting a rook doesn't do anything, but so we have kind of bug. I think this is because did I click outside? I thought I just clicked inside. Let me try that again. Okay, because when I attempt to make a move, it's generating valid rook positions. Sure. So let's go to the output. So selected the piece, and when you select the piece, it automatically generates rook positions. So I'm not actually sure why 8,5 was the index that came into play. Let's see, on piece selected, generating valid move positions, and then it went into pawn positions. Because the diagonals are outside. Right, so what this kind of means is you should just do a filter on the final valid positions. Where you can specify a function position within bounds. Let's stop this for a while. Just want to see what this error is. The shadowing is not that much of a concern. Let's see, return. Okay, maybe this is what it's looking for. Yep. And we'll do the same thing for Rook. So every time just make sure that you filter out anything that's not in bounds. Let's try this. Still came over here. That is because when you check if the position is occupied, you're already sending in the diagonal, and this filter here doesn't matter. So let's remove this. This doesn't solve the problem. And what I'm going to do here is, I think it's up to philosophy. So if checking if position occupied, but here you're not validating if it's within bounds, and it's the same thing, I believe, over here. So this should also actually cause a problem if I just basically start moving all the way ahead, and then if I click on this pawn, yes, so this is again happening because we are not validating these positions. So I think maybe position occupied. So the thing is, it's technically not occupied, but it's not within bounds either. So what I'm going to do is, that's all right. And I don't know why I have such a complicated function here, because this is just checking if position is in my board dictionary. So I'm going to actually remove this. and wherever I had that, if board okay, I think this is good enough. Now let me quickly check this. If I do this, I need to filter out things that are not in the board. So I'm going to apply the filter at a global level over here. Let's just call this, do some refactoring here. Valid no positions is this, and here if it's a pawn, we use this function. If it's a rook, we use this function, and we remove this, and we just filter out everything that's not part of the board. So it's a function which is position on the board. So anything that's outside automatically gets removed. Let's try this. Okay, seems to be fine. So there is another bug that I apparently haven't used. So what if I don't do this filter? Weirdly that works. Let's look at the rook. Okay, I think I killed it. Not sure what failed there. Oh, give me a second. This is possibly, is this the while loop that is causing a problem? Yeah, I think so. For each of this, while this is in board and the position is not occupied, do this, and then your target position is never updated. So it went into an infinite loop. Let's do this. Yep, now works. You can see it's properly calculating all the possible rook positions, and it also supports capturing. And if you select a rook that is blocked by your own pieces, you cannot capture. So let's just move this and bring this out. Okay, looks good. Now what we need is a similar function for the knight. Let's quickly go ahead and add this for knight. And I'm going to say generate valid knight positions, and the signature is going to be the same. This is going to be a bunch of copy paste, I believe. And yeah, so let's again create an array to which we'll be appending valid positions. Turn the array at the end, and here we're going to have some logic. So the knight can move 2 steps in one direction and then 1 step in an orthogonal direction. So basically, if I were to go here, let's select the knight, and you can see basically 2 steps down, 1 step to the right, 1 step to the left, or 2 steps up, 1 step to the right, 1 step to the left. So basically the knight can always move to only 8 possible pieces, 8 possible positions. So it should be fairly straightforward to calculate. And again, what I'm going to do is for each direction, my target position is going to be, so actually let's do this slightly differently. So if it's up and down, let's call it a sub-direction, which is going to be left and right. Left, and what we're going to do is my target position is going to be the initial position plus 2 times the direction, 2 steps in one direction plus the sub-direction. And I'm going to do the same thing if the position is not occupied, then just, so there is a lot of ifs here, which I believe I can refactor and clean up. The target position being in the board is something I believe I can move to later, but the problem is I have certain checks on whether there are different colors. So it gets significantly complex. It's alright for now, I'll do the refactor later. So if the target position is in the board and it's not occupied, then just append it. But the problem here is you don't know so here means it's occupied. Just check if it's an enemy, which is going to be like this. This is going to be a capture, so again suspend this. So we covered up down and then right left. See, she's so this only covers 4 moves. How do I make it cover? I can just copy paste the entire thing and then flip the right, left and up down. Basically flips direction and subdirection, but it just seems a lot of repetition. So let me see if I can do this in a slightly better way. If there is so basically the contents of the inner loop are just going to be the same. Right, it's kind of ugly, but it's alright for now. Say validate my positions given a direction and a sub-direction. This entire thing is I'm going to go here. Okay, standalone lambdas cannot be accessed. Alright. I guess I'll just make this a function outside. This is actually kind of getting ugly. Let me just move this inside and like it being outside. Oops. This right here is the biggest piece of copy paste I've done so far. Okay. And actually, this should be good enough. The good thing with the night is it doesn't. Okay, so the thing is, it means it did not generate the positions properly, or something wrong. So for this, it's going to be 2 times up and 1 time to the right if the target position is in board. If it is not occupied, valid positions dot append. So this should have ideally returned position. This is a problem because I'm assuming it's a rook. Okay, now I can see I can move the knight and it shows all the proper positions. Let's see what happens when owner knight moves. It allows me to capture, and now this is a proper representation of all the places the knight can move, because you can capture this knight or you can move to any of the free positions. Let's try to move from here, and you can see that if it's already occupied, it doesn't show that as a valid position. Okay, so that finishes the knight. It was kind of an ugly function, but I'm done with it. So let's quickly go on and say rook knight. Now we're going for the bishop. Yet again, we do something similar, and I have a feeling this is going to be similar to the rook, because we're just going to go along a certain position and see if there is either a capturable piece or a piece blocking the way. Just actually going to be away from keyboard for a minute or so. Alright, so checking if I'm still streaming, check YouTube just in case. So if it is a bishop, then you have 4 diagonal directions, and in this case the directions are going to be not just pure up or down vectors. In fact, you either move one step up and one step to the right, which is 1, 1, or you have up and to the left, which is 1, -1. Then you have down to the right, and then down to the left. So in each of these directions I do the same thing as I did for the rook. The target position, add the direction. If it's in board, not occupied, then do this. Okay, all of it looks similar, so I'm just going to go ahead and this, and let's see if we can actually get this working. So right now the bishop doesn't move, but if I do this, yes, it does move. Let's go ahead and do this. Now you see highlights all the possible positions, and you can also capture this. I'm going to click here. Let's do this, and yeah, you can capture here. All of it seems to be working fine. Let's test it with the black bishop, and yes, so all the capture positions are working fine right out of the box. Finally, you have just the queen and the king, which I'm going to be quickly setting up now. So the thing with the queen is it's basically just a combination of the rook and a bishop. So I should be able to get away with just appending the 2. Check if that works. It should actually work. Now it doesn't do anything, and you can see, yes, I can move, and it shows all the possible positions for the queen. That is a lot of positions, by the way, but yeah, expected since it's the queen. I mean, okay, come here, let's go here. Yes, you can see the queen is very well positioned. Great, so I think all of it just works. Alright, and finally we're going to do the king. So king, the reason I need piece is basically to identify if it's the black or white king, but in this case I have a feeling it doesn't matter. Or does it? It actually does, because you're still going to have to check whether it's blocked by a friendly piece or an opponent piece. So now it's the same as possibly, for example, the bishop, except now you have 8 different directions in which the king can move. This is actually a vector to I. Then you have right and left. Each of this, and you don't need a while loop because the king can just move one step. So if the target position is in board and it's not occupied, then just append this. So what I'm going to do is target position in board. If not occupied, then just do this. I think this is actually a better way to represent what I've written in a bunch of places here. But okay, again do the refactor. So done. Let's go ahead and run this. King currently can't move anywhere. Can move here, and yes, it does seem to be working. Right now, it doesn't check whether the king is in check, so it's kind of a bummer, but you can see that I'm able to capture and move the king properly across the board. Okay, so that basically finishes basic chess setup. Now there are a lot of other things to do. For example, finish making sure that the valid positions check if the king is in check, otherwise you reject that move. Then you have en passant, then you have a game manager which makes sure that white cannot move consecutively, or even black for that matter, because right now I can just keep moving all my white pieces. This is not allowed. And of course there are other things to consider. For example, right now the king cannot castle. That is a move that we need to allow. And then you obviously have the en passant, which is the pawn should be able to capture a pawn when an opponent pawn when it is fairly advanced across the board. So in this position, the white pawn can technically capture this black pawn. This I believe is possibly simpler to implement, but yes, so basically there is no concept of check, there is no concept of en passant, there's no endgame, there's no checkmate, there's no castling, and there's no pawn promotion. So once all of these are put together, this is going to be a complete chess game, and I hope to take that forward in the next live stream. So managed to accomplish fairly a lot this session, so I hope to complete all the complex parts in the next session. So that's it for today. I'm going to stop the stream now. Thank you.